Okay, students, we are going to go ahead and look at the notes that are also discussing the lab that we did on organic systems, and it's listed in the chapters Organic Systems Review, Chapter 6 and 7. So I just want to go ahead and go on with what we're doing here is notice as we look at these reactions, combustions are all chemical changes where we have organic molecules combining with oxygen, and then what happens is it goes to water and carbon dioxide. And notice energy is given off because it's actually a chemical change. So if we had a fire burning a tree, it would be undergoing combustion. And this energy is also the same metabolism that drives the processes or cellular processes within our bodies. When the organic molecule is glucose and it's broken down for energy for our body. So you take glucose plus oxygen and it goes into a chemical change where we get 6 CO2 plus 6 waters plus energy being given off. And a lot of this page is a lot of the review of what we did in the lab. So we see that carbon has a total of 4 bonds, 8 electrons. Hydrogen has to be on the exterior because it can only have 2 valence electrons. N has 3 bonds and a lone pair. Sulfur and oxygen have 2 bonds and 2 lone pairs. And the halogens have to have 1 bond and 3 lone pairs. And then you see these are the same bonds that we had on the lab. And some of the properties of our organic compounds, where they're flammable, high vapor pressure, smelly, covalently bonded, nonpolar, low water solubility. Molecules that have oxygen or hydrogen in them, or nitrogen and hydrogen will bond with hydrogen, so there's going to be some solubility. And the rate of this chemical reactions are going to be pretty slow. And these are normally all found as gases and liquids at room temperature. So let me flip the page here. And what you're going to see on the second page of this handout is one side of your cheat sheet that you had. And you should see that sheet listed, and you'll see here it's the alkanes, and it's got all the structural formulas, and then it gives you the names for all of the numbers of carbons from 1 to 10, all the way down from methane all the way down to decane. So that should be on one side of your sheet that you can use on your exam for chemistry. And then the 3 different types of formulas, the molecular formula, which we list as C4H10. This would be the structural formula for that, so it shows all the attachments. A condensed structure takes out all the bonds and just has the CH3 that's written here, CH2, CH2, CH3. Okay, and then a line structure, so wherever there's a point, there's carbon, and then I've got bonds here, so there's a carbon in each one of these tips. Okay, and the general formula for a cycloalkane is a CnH2n, so it doesn't have a +2 or a +1, it's just the CnH2n. And then we've got our alkyl groups, which we talked about in lab. So methyl, ethyl, propyl, isopropyl, and the alkyl halides have a halogen instead of an alkyl group as a side group. So they can have a chlorine, a bromine, a fluorine, or an iodine. So those are all the things out of column 7A that we talked about. Okay, so, and on your cheat sheet there is also a list of rules for identification here. And as we look at this, you'll see that we want to identify the longest chain, carbon chain, and circle it. We'll then ID the side groups and their names. You number the C position on the chain where the side group connects and give it the lowest number possible. So you can look at it from both ends, but you have to start with the carbon with the lowest number first. We use di, tri, or tetra for multiple groups of the same type on the compound. And notice that there are hyphens, spaces, commas, etc. between numbers, and words we add a dash, between numbers we add commas. Okay, so let's look at this one as an example. Okay, so we want to do a 2,2-dimethylpentane. So the first thing we're going to do, pent means 5, right? So we are going to make a 5-carbon chain. Okay, so it says 2,2-dimethyl. So methyl is a CH3 group, because methane is CH4. So we have to go to our second carbon. So we'll start numbering from the left. So we go 1, 2, and I'm going to have to draw right through this thing. So I'm just going to make it go up here. So I'll put a C there, and those 3 lines mean there's 3 H's on there. And I'll go down through this one and put a C. So this is a 2,2,2-dimethylpentane is how that looks. Okay, so now let's try this one, and I'm going to go down here to go ahead and draw this one. All right, so I'm supposed to draw the structural formula for 2-methyl-3,3-dichloropentane. So we still do the same 5 C's, right? Okay. 2,2-dimethyl. Oh, sorry, wrong one. 2-methyl 3,3-dichloropentane. Okay, so I'm going to have a methyl group coming off the 2, and off the third I'm going to have a chlorine off of each. Okay, so we come into here, there's 1, 2, 2-methyl 3,3-dichloropentane. Okay, so that's as far as we went for today. So what I want you to do, and basically you can look at these other saturated hydrocarbons and the cis and trans portions. The 6th page of the lab is your organic functional groups, which you should be on the other side of your cheat sheet. So you have the organic functional groups and then the names for all the prefixes. Okay, so what I'd like you to do, you can look over page 7 on your own. As we look on page 8, what I want you to do is use your organic functional, or excuse me, your functional group sheet that looks like this, and look at the structure here for Flonase, and you can see that I've looked at a couple different groups. If we look at this one here, you'll see I have a CH3 carbon, a double bond O, another O, and another carbon group. Okay, so if I look under esters, you'll see I have a C double bond O, O, C with another group. So this group right here is an ester in here. Okay, you'll see I have the same thing here with a C double bond O, C, O, and in a group, and I've got a sulfur and a fluorine. So this one is still an ester, but because it has sulfur in it, it's a thioester. If I was looking for another group, you can see here I've got a ring, okay, and I've got a OH for an alcohol, because if you look here on this one, you'll see I've got a alcohol as a carbon with an OH group. The O is always attached here. So with a phenyl ring, this would be a phenol group. And if I'm looking at my other groups with the double bonds, as I see here, if you look on your sheet up here, you can see that right here with a ring with a double bond alternating with a single bond is a phenyl group. So I would have here a phenyl group. And I can also look at that if I've got a double bond O with a carbon. And I've got a R group on the other side. Let's see what I have. Double bond. I don't have another O, so it can't be an ester. The O's got to be in the middle. We got a C double bond O with an H. Okay, that could be an aldehyde. Okay, so what I want you to do is take this sheet and look at the others. Let's go ahead and just do number 1, and then we can go on, and I'll let you do 2 and the other page, which is actually 9 and 10 on your own after we have the quiz tomorrow. So if we look at this, it goes, which of the following structures is an amide functional group? So let's go and look at our sheet. It's in the bottom left-hand or bottom right-hand corner, and you see an amide here has a C double bond O NH2. So if we look at all these, there's no N here, no N here, no N here. Whoops, there's a C double bond O NH2, so it's got to be D. Okay, so for Wednesday, we'll go over the structure groups that are found in this particular structure of pantothenic acid, and then we'll also do pages 9 and circle the functional groups on page 10 as well, and that'll be on Wednesday since we have the quiz tomorrow. Okay, so I wanted to do just a little bit of a brief review for the quiz on oxidation reduction, and I know I had these online, but let's go ahead and look at the answers for your oxidation reduction. If we go through which of these statements is about rust is incorrect, rust occurs as a result of transferred electrons. That is true. Rust is a result of an oxidation reduction reaction. That's true. Rust is accelerated by the presence of salt water. That's true. Rust causes $10 billion worth of steel destruction annually. That's true. Iron is reduced and oxygen is oxidized. That is not true because the iron is oxidized. That's what happens with rust. So letter E would be the incorrect statement there, so that would be the right answer to put down. Okay. Number 2, during oxidation reduction reactions, the substance which loses electrons is A, oxidized, and the substance which gains electrons is reduced. That's just the way it is. Oxidation loses electrons, the things gaining electrons is reduced. Okay, so if we have to look at on number 3, which is a characteristic associated with oxidation, we just talked about number 1, that it's losing electrons. If something's being oxidized, it does not gain hydrogen. Okay, let me move this down. If it's oxidized, it does gain oxygen. So 1 and 3 are correct statements, so our answer has to be C. Okay, and number 4, it asks which statement about redox reactions is incorrect. Oxidation is a gain of oxygen. That's true. Oxidation is a loss of electrons. That's true. Reduction is a gain of electrons. That's true. Oxidation is the gain of hydrogen. That is not true. So D is the correct answer. Okay, and the last question on this page, number 5, wants to know which of these is not an oxidation reduction reaction. I've got copper. Okay, losing, copper is reduced. Okay, so there's an oxidation. I look here. I got CO2 being reduced. I look here on the number C. I have nitrate going into nitrous gas. Okay, so basically I've got it losing oxygen, so it's being reduced. I've got manganese hydroxide plus manganese oxide aqueous, and we can see that that goes into MnO4 2-, so it's gaining electrons, so that's oxidized. I've got a strong acid, hydrochloric acid plus Sodium hydroxide goes to sodium chloride plus water. That's a acid plus a base equals a salt plus water. So that's not an oxidation, that's an acid-base reaction. So the correct answer is E. Okay, and remember you're going to have 12 of these questions tomorrow. Number 6, which substance is the oxidizing agent in this redox reaction? Okay, so the oxidizing agent is whatever is reduced. Okay, so if we look at that, it looks like the MnO4 is being reduced because it loses its oxygen, so the answer would be B. On question 7, it says which substance is the reducing agent in this redox equation, so whatever is being oxidized would be the reducing agent, and that would be letter A, hydrogen fluoride. Okay, because the F2 goes from -1 to 0. Okay, so it's losing electrons. Okay, which of these substances is the most common oxidizing agent? And I hope you answer C, which is oxygen. If that's the most common oxidizing agent, which of these substances is the most common reducing agent? And number 9, and hopefully you'll answer hydrogen. Letter A. Last two on this page, 10 and 11. Which of these statements about respiration is correct? And you can be guaranteed I'm going to ask at least 1 or 2 questions on photosynthesis and respiration. So if we look at number 10, if we look at that, carbon is oxidized during respiration. That's correct. Respiration is an exothermic process. That is correct. Carbon dioxide and water are produced during respiration. That is correct. The final step of digestion requires oxygen to oxidize glucose. That is correct. So the answer would be E. All these statements are correct. Okay. I hope nobody misses this question if I put it on the test. The process by which plants form glucose is known as B, photosynthesis. You don't even need to know oxidation reduction for that one. Okay, we've just got 9 more questions to go through for the review here. Okay, so in respiration, sugars are what in the presence of oxygen? In the presence of oxygen. You better answer letter D, oxidized. Which of these pairs represent reactants in photosynthesis? So what's on the left side of the equation to help me make sugars? And I would hope that you would answer water and carbon dioxide. That's what it takes to make the sugars. And energy. I just don't have energy on there. Okay, for number 14, which of these equations correctly represents photosynthesis? Okay, so I just said it takes carbon dioxide and water. And the only equation that has carbon dioxide and water on the left is letter E. And sugars are over here. This is respiration up here on D. So don't get confused with that. Okay, number 15. Which of these substances is oxidized? So what's gaining oxygen? And I see more oxygen on the CO2, so that should be letter B. Carbon monoxide is oxidized. And it says which of these are oxidation reduction reactions for number 16. Okay, so we got 3H2 plus N2 going into 2NH3. That's an oxidation reduction. I see carbon gaining oxygen. That's a oxidation reduction. I have iron oxide going into iron and CO2, so that's an oxidation reduction. I have 2K, so that's plus, and Br2 with his, because that doesn't have a it's actually going to be an oxidation reduction because it goes from a 0 to a -2. So basically all of those are oxidation reduction, so that's letter E. Okay, we just have 4 more questions to review here. Okay, and you can guarantee I'm probably going to ask a question about batteries. In electrochemical cells, letter A, oxidation occurs at the anode, reduction occurs at the cathode. Okay, so oxidation is the loss of electrons, so I lose the electrons here and I gain them over at the cathode. Okay, for number 18, which statements about the lead-acid battery, statement about the lead-acid battery is correct? That's kind of a giveaway there. So you see the equation. Lead is oxidized, that's true. Lead oxide acts as the cathode, that's true. Both the anode and cathode result in the formation of lead sulfate, that's true. Lead and lead oxide can be reformed from lead sulfate with the application of an outside electrical current. Think what happens when you start the car. It goes back the other way and recharges the battery, so that's true. So it is letter E. All of these statements are correct. Okay, our last two, 19 and 20. Which of these methods are utilized to help prevent the rusting of iron, which we call galvanization? So we talked about we could paint the iron. I don't think you'd treat the iron with a sulfuric acid. That would probably promote iron rusting. Or you can coat iron with a metal, which is more likely to oxidize. So 1 and 3 are correct, and that is letter C. Last one, which of these is an antioxidant? Okay, if we talked about antioxidants trying to get rid of the free radicals, and if we look in the literature, vitamin E is an antioxidant, vitamin C, beta-carotene, those are all antioxidants, so your answer would be D, all the above. It couldn't be none of the above because you've got E and C are both antioxidants. If you weren't sure about beta-carotene, you know E and C are because they're recommended for that. So that is the end of the review, so good luck on your 12-question quiz tomorrow.